In this video, I am going to solve the problem 44 from chapter 19. At 546 Kelvin and 2 multiply 10 power minus 2 atm, the density of the gas is 1.24 multiplied 10 power minus 5 gram per centimeter cube. First question, find the vrms for the gas molecules. Second question, find the molar mass of the gas. And the third question, identify the gas. So by seeing the table. So we are going to get one answer, and by using that answer, we are going to cross check that value with the table, and after that we are going to identify what should be the gas for that value. Clear? Okay, let's we answer one by one. And first of all, I'm going to write the given. So what is given in the question? In the question, they mention the information about the temperature, which is 546 Kelvin. And also they mention the pressure. So the pressure here is 2 multiply 10 power minus 2 atm. So I have to convert this atm in terms of Pascal. So you have to multiply 2 multiply 10 power minus 2 with 1.01 multiplied by 10 power 5. We will get the answer in terms of Pascal. So the value for the pressure here is 2.02 multiplied 10 power 3 Pascal. Clear? And also the gas density given here rho, which takes the value of 1.24 multiply 10 power minus 5 gram per centimeter cube. Now we have to convert this gram per centimeter cube in terms of kilogram per meter cube. For that we have to do the conversion. So first of all, we will complete the conversion, and then we can just go for answering the question one by one. So rho, which is equal to 1.24 multiply 10 power minus 5 gram over centimeter cube. So now I'm going to convert that centimeter cube. We already know 1 centimeter cube, which is equal to 10 power minus 6 meter cube. Likewise, we studied the conversion for kilogram to gram. So we know 1 kilogram, which is equal to 10 power 3 gram. So by that we can easily cancel gram with gram and centimeter cube with centimeter cube. By that we will calculate, we will get the answer for this density in terms of kilogram per meter cube. So therefore the rho we got here as 0.0124 kilogram over meter cube. Okay, now we are going to answer one by one. In the first question, we are going to find the answer for vrms. As we already studied the relation in the theory, vrms is, we can calculate the vrms by using the relation square root of 3RT over m. Now we can't use this equation immediately. Why? Because we don't know what is the gas. If we identify the gas, then only we can easily use this relation. So for that, what I'm going to do, first of all, I'm going to use the ideal gas equation. So what is the ideal gas equation? Ideal gas equation, PV, which is equal to nRT. And here P stands for pressure, V stands for volume, and N is the number of moles, R is the gas constant, and T is the temperature. So now what I am going to do, I'm going to first write the rule for the number of moles. What is the formula for number of moles? The number of moles should be given by the rule the mass of the substance over the molar mass. Now I'm going to take this formula and I'm going to substitute here. If you substitute, what will happen? This equation will become PV is equal to the mass of the substance multiplied by R multiplied by T over the molar mass. Now I'm going to move this molar mass to the left hand side, and I'm going to move this volume to the right hand side. By this equation will become PM, P stands for pressure, caps M stands for molar mass, which is equal to the mass of the substance multiplied by R multiplied by T over volume. As we already know the rule for the density which is equal to mass per volume, right? So the density which is equal to the mass over volume. So we can easily rewrite this equation as PM, which is equal to rho multiplied by RT. So here what I'm going to do, I'm going to rewrite this equation in terms of rho. Therefore, rho, which is equal to PM over RT. Now I'm going to use that vrms equation. Vrms is given by the rule square root of 3 RT over M. So now you have to see this row as well as here. Here we have RT over M, but here we have M over RT. Now what I'm going to do, in place of RT over M, I'm going to substitute this rule. By that, our vrms is become vrms. Now it is changed in terms of density. So the formula here is entirely converted in terms of 3 multiplied by pressure over rho. So what I did, so in place of RT over M, I just substitute the value here. So here in rho we got mass, pressure, mass over RT. So here mass over RT we have. So I just take the reciprocal of this, right? Now I'm going to substitute the value for getting the answer for vrms. Therefore vrms, which is equal to 3 multiply the pressure we already converted in terms of Pascal, which takes the value of 2.02 multiply 10 power 3 over the density we got as we already converted in terms of kilogram per meter cube, so 0.0124. So if you want, I can just show, because we already converted these two. So pressure, I just use this value, density, I use this value. Clear? Okay. So now if you calculate, we got the answer for this vrms, which is our first question, takes the value of 699 meter per second. So this is the answer for the first question. Clear? Okay. Now we have to answer for the second question. So what I am going to do, I'm going to use this rule. Which rule? I'm going to use this rule. Which rule? Rho, which is equal to PM over RT. For getting the answer for the second question, we are going to find the molar mass, right? So for getting the molar mass, which is capital M, we are going to find this value. So for that, I'm going to take this rule. Which rule? This rule. Rho, which is equal to PM over RT. Now I'm going to rearrange this equation in terms of molar mass. Therefore, molar mass is equal to rho multiplied by RT over pressure. Now we have all the values. I'm going to substitute the value for the rho 0.0124, which we already did in the first part, multiply with the gas constant 8.314, multiply with the temperature is already given in the question as 546 over the pressure is given in terms of atm, we already converted in terms of Pascal. So when we converted in terms of Pascal, we got 2.02 multiply 10 power 3. So if you calculate this, we will get the answer for the second question, which is a molar mass. What's the value for molar mass? We got the answer here as 0.0279 kilogram per mole. Or if you want to write in terms of gram per mole, we'll get the answer 27.9 multiply 10 power minus 3 kilogram per mole. Or if you want to write in terms of gram per mole, which is 27.9 gram per mole. Clear? So three answers are right. You can use any one, but we have to find what should be the gas, right? So here we got the answer here as in terms of, let's we take the value in terms of kilogram per mole. Okay, so what answer we got? 27.9. Better we can just rounded this value. So if you just rounded this value, we got 28 multiply 10 power minus 3 kilogram per mole. So we got the answer here as 28 multiply 10 power minus 3. Now I'm going to compare this answer with the table. Let's we just go back to the table. I already pasted the table here. So here you have to see 28. We have the answer. Am I right? In the second part, we got the answer as 28 multiply 10 power minus 3 kilogram per mole. Am I right? Here also we got the answer 28 multiply 10 power minus 3. That means the answer for the third question, we already identified the gas. So the molar mass 28 multiplied 10 power minus 3 kilogram per mole is for nitrogen gas. So what's the gas here? Nitrogen. So this is the answer for the third question. Clear? That's it. Thank you.